Welcome back to the arcade. Today we're going to try to repair this Gorf RGB interface board that I got about a week or so ago, and it appeared to be damaged in the mail. It got smashed. The two delay coils here were kind of smushed down against the board, and let's see, well, this is the good one here. This is the one I have hooked up right here. Okay, it's double wrapped, triple wrapped. It's kind of like one of these Christmas gift gags or birthday gags. You know, you get a package in a package in a package. Well, can't say it's not well protected, but in a soft pack like this, it can still get smashed. So, okay. All right. Yeah, it definitely got a little smashed, but ought to be able to straighten up. It's just these coils here got hard wires. They're soldered to the board and then they're soldered to the coil, and they kind of got smushed over here. And the only concern is going to be right there. It looks like it tore into the cover that was over the coil, and you can see the coil right there. I hope it didn't bust that coil loose, but anyway, we'll see if we can't straighten it up here. And hopefully it's not enough damage to matter. Just straighten it right back up. And we'll straighten this one up. Okay, that ought to be good enough to try it out. And this mounting screw, it had gotten smashed against the mounting screw and cut into the cardboard covering the coil. And I don't know, it looks like I know it took some of the insulation off of the magnetic wire of the coil right here, but through examination under a magnifying glass, it looks like it's still intact, so that really shouldn't affect it. So anyway, let me turn it on and show what it's doing. I think it's a little bit worse than it was last week. It's turned more green. So let me zoom into the screen here. At least last week when I tried it, the first time, that was a little bit yellow, the writing, which is supposed to be yellow, but the Space Invader screen was green instead of blue. So it appears that it was missing the color blue. As you can see there, it's green. And now everything is pretty much green. So it's definitely got a problem, and it's worse than it was the last time I tried it in the last video. So let me cut this off, and I'm gonna hook up my good RGB board that's out of my Gorf game that I've been using. just to show anybody that hasn't seen it before what it's supposed to look like. And this is what it's supposed to look like. Let it get to the Space Invader screen and you'll see that the background is supposed to be blue instead of green. And there you go. As you can see, we got blue, we got red, and we got green. So that's what it's supposed to look like. Okay, well, how are we going to figure out what's wrong with this? Well, luckily, I got a good board to compare the bad board by, and also have the schematic. So hopefully we can kind of figure out what's wrong. Now the only components here that I would think would be bad would be they listed here as 270 nanosecond coils, and this is a delay coil. Now I don't know exactly what that means, but it is exactly what it sounds like. I did do a little reading on something similar to this, and the delay coils are needed because this is converting component video to RGB video. Component video has the three outputs, which are video, BY, and RY. Now, the BY should be the blue signal, and the RY is the red signal. The video is a combination, it's a composite signal that you can run black and white. And it also contains the chroma information, I guess, or the luma information. Luma information, I think, which is the brightness. So anyway, I don't know exactly how it works, but somehow it takes the video, which right here on the schematic, these are the three inputs. They call it the video, the BY, and the RY. And after it goes through the board, it comes out with red, blue, green, and sync, which is your standard RGB output that goes to the arcade monitor. Okay. We have sync, so the transistor on the board, it's got one transistor, a 2N4401, that splits the sync off of the video signal that's coming in. It's also got a Zener diode here, an IN5232B. That has something to do with converting the composite signal, separating the sync so that you get just your standard green output for the RGB. Because if you were to hook this right here, the video, where it comes into the card, directly to composite video on the monitor, you would get a picture, but it would be black and white. So that's what this does right here. And from what I understand, in order to, when they split this signal back, to turn it back into the green and the sync, it has to have some type of a delay for the other two color signals. And that's why it's got this coil in each one of them. It's a delay that I guess puts everything back into sync. I don't know, you know. I mean, that's all I know about it. So very basic understanding. I know it's probably a lot more to it than that, but it looks very simple. And you got this one chip, a TBA 530, which is an RGB matrix preamplifier. So it takes the different inputs and I guess puts the signals back in alignment. I don't know. Anyway. So anyway, it's my understanding that this chip often goes bad. Okay, so it could be the chip that's bad, or it could be the delay coils are bad. So that's what we're going to have to determine. Now, I did order a new IC, a new RGB matrix preamplifier, the TB-A530. So I do have a new chip. I could just pull that out and put it in, see if that fixes it. But first we'll do a little basic troubleshooting to see if we can't see if we have a problem with the coils, if the coils are good or bad. We ought to be able to take an ohm meter reading and ohm it out. And if you look on the schematic right here, these coils has, one side has a line and it's got a ground on both sides. Okay, on the top half here, we just have a coil. And there's no physical connection between these two. So they're insulated, okay? Now, from my understanding, what it is, these coils here has this round tube, and half of the tube on one side, and it looks like it's on this side right here, has a copper strip on it. It's like an adhesive copper like you would use to repair a trace on a board, and it's got to be a certain width, because I believe if you look right on the edge you can actually see it, and it's just like it's adhered to or stuck to the cylinder, and it covers one half of the cylinder. Then you have these two terminals that go all the way through the tube and are crimped on the inside of the tube, and then you got the wires that connect that and go down to the board. Now these two on this side right here are the ones that goes to the ground on the board. So the two outer terminals on each one of the tubes is this right here on the schematic that goes to the ground. So that's kind of like a, I guess you could call it like a ground shield. Okay, but it has probably something to do with the capacitance between the coil and the ground. Like I say, I don't know exactly what it does, but that's how it's physically made, in my understanding. Then on the other side, you have two more terminals. These terminals are not connected to that copper shield that's on this half of the coil. These two are where the coil itself attached to, and in between those terminals is the coil wound across the top of that copper strip. And of course it's I think a plastic insulator over top of the copper, so that the insulation of the magnetic wire, if it was to start coming loose or wear, it wouldn't short to the ground. And that is how the delay tubes or coils are made. So what I'll do first is I'll take my good board here, and let's see if we can get a reading on it. Okay, let's see if we can get a reading on this. First I'll put my leads together, so we'll see if we zero out. This meter is pretty good at zeroing out. So yeah, see, we don't have any resistance in the test leads, so that's good. Okay. All right. First, let's test the ground connection. Okay. So we'll put it here and here. And if we can make a good connection here. It's a little corroded. Okay. You see that is 0, so that's a direct short. So this is the ground side of the coil. All right. Let's turn around and let's check the other side to see if the other side is identical. And it is 0 ohms, so it's like a dead short across there. Okay, now this is the good board. Let's take the bad board and let's do the same thing. All right, getting the same thing. We're getting the short, so that's good. And we're getting the short on that one. Okay. Kind of expected that, because unless you got a break in that copper somewhere, would be the only reason why you wouldn't have a dead short across there. All right. Now let's check the coil itself. So that's on the inside of the board. So let's go ahead and check this. And we are getting 32.5 ohms. Okay, let's check the other one. 32.7. So that's pretty doggone close. So we can determine that the good coil here, it seems like we're getting a good reading on there. 32.5 on one. And 32.7 on the other. Okay, let's try the bad board and see what we get. Again, we're doing the coils, which are on the inboard side. So let's put it on this one. That ain't good. 2.924K. So that's almost 3K, 3,000 ohms. That is totally different. All right. Let's try the other coil here. All right, this one we're getting 28.5. So that's a little bit lower than the good board, but 28.5 with a coil like this, I would say that that's okay. So I would say this one is good. But this is the one that had the damage on it right here. So that's the one I would think would have been bad. Now, the other thing is this coil here is labeled as DL2. And if we look at the schematic, DL2 is up here. And that one is associated with the red signal. And we don't have a problem with the red. Well, actually right now we don't have any red. All we got is green. Green is down here, which has nothing to do with the coils. The other one is for the blue. That's DL1. And this is DL1, the one that I suspected was bad because it had that nick in it where you could see shiny copper on the magnet wire there on the coil. Okay, so what does that tell us? Do we have an actual problem with the coil, or is there the chip maybe shorting out? Well, let's see. No, we're getting more resistance. because we're taking a reading across the coil direct. So it shouldn't have anything that's in the circuit shouldn't have an effect on it. So I would think we got a problem with the coil. And that's bad because you can't get these delay coils. All right, tell you what we'll do. Let's go ahead and pull them, or pull one of them out of circuit, and we'll test it again and see what we come up with. Okay, well, I've desoldered one of the coils here. I actually desoldered DL2. So DL2 is the one that does the red signal. Okay, since it looked like we didn't have any red. I think we had red originally last time I had tried it in the other video, but now I don't have red or blue. Seems like I only got green. So we'll start with this one. This side right here should be the one that is on the shield, which should be grounded. So this side here should give us a short. And it does. It gives us a short. Okay. Now this one here should be the coil. So let's see if we get anything on this. And we're getting absolutely nothing. It's an open circuit. So we got a break in that coil. Now, from what I've seen online, a lot of times see if you can pick this up. See how that wiggles? It's wiggling in the tube right there. So the ones that the coil is on wiggles a lot. Now the one that the shield is on, I think they're soldered directly to that shield. They don't have any wiggle to them. So the one over here with the coil is a real fine magnet wire that's hooked to that coil. A lot of times, from what I've been seeing online, and it's not too much online about this, but I do remember seeing this, that wire from the coil that goes to this terminal will break right here, and sometimes you can put them back together. So I'm going to have to peel this covering off of here. I don't know if it's glued on there or whether it's just a tape. It kind of looks like it was a piece of tape. It's got the jagged edges right there where it looked like it was ripped off of a roll. So I don't know. So let me see if I can very carefully unwrap this. And yeah, it appears to be something similar to masking tape. But you know how masking tape gets when it gets old. It gets brittle and just wants to come apart. And it's left glue behind. There's the coil right there. Try to be real careful. I can see the real thin magnet wire right there. Wonder if I soak this in maybe alcohol or something, it just might make a mess. we got it off. Now we have to look and see if we got a break in that wire. So let me take my magnifying visor and see if I can't see that. And if I do, I'll put the macro lens on the camera and see if I can't show it to you. Okay, sure enough, I found a break. Let me see if I can get it in here where you can see it. I don't know if I'll be able to or not. Look right at the base where the coil meets there. See it right there? See the little wire? It's broke right there. Right to the right of the terminal. Very hard to get this. There you go. You can see it jotting off to from the terminal to the right hand side. And right there is, I got a shadow on it there. There you go, you might be able to see it right there. But that's where the break is, right there. So, we're going to have to try to patch that back together. All right, let's see if I can do some microsurgery. I'm wondering how critical that coil is if I was to unwrap one round so I'd have extra wire, or if I should just take a piece of wire. I think that's what I'll do. I'll just take a piece of a wire, scrape that insulation down on top of that, try to tin it with some solder, and then just try to put a bridge across it. Yeah, I think I'll try that. All right, let me see what I can do. Okay, first I put a little red mark right here so I know this is the end that has the broken wire. And so now I need to be careful with this other end because that thing is wiggly, and if you wiggle it too much, that end will break, and I don't want that end to break because I don't want to have to fix it. All right, I got my little emery board right here, and what I'm going to try to do is I'm going to try to scrape the insulation off right here so I can get some solder to stick to it. And I'm probably going to have to get out of the camera here because I'm going to have to use my magnifying glass here to see what I'm doing. It's kind of good that glue is holding it down. Okay, now I got some of the insulation peeled back. Maybe I can get some solder on it here. Let's see what that's doing to it. That's just melting that, that tube must be plastic. So I can't do that. Alright. I'm going to have to try to lift the wire up. Yeah. Okay. Try to scrape off some of that insulation, which is enamel. Alright, now I got it up in the air. I ought to be able to burn that off and get some solder to stick to it. Alright. See what that looks like. And I believe I got some solder to stick to it. Okay. Now I'm going to take some of this wire. I forget what they call this stuff, but this is the stuff you use to run patches on PC boards. It's got a solid like copper wire that's coated with like I think it's a Teflon real you know, tough stuff. So you know, it's a good insulated wire to make repairs on PC boards with. So let's see if I can expose a piece of this. Okay. Now let's see if I can tin this. Okay. I'm going to cut it off and leave it a little long. Now this is the part that's going to be difficult, because that wire is so little I can barely see it. If it was up higher, it needs to be up higher. Let me see if I can find something I can get it up a little higher on here. Oh, let's see. What have I got around here? Get the stuff out the way. it helps to get your work closer to you. So see if I can zoom in a little bit. Don't know if I'm gonna get this, but I'm gonna give it a try. All right, I gotta get down here where I can see it. Oh, that's too close. All right, let me put my other magnification down. See if that'll do it. All right. Need some solder on the situation. Might be going about this the wrong way. But I'll try it this way first. Okay, I got it on that. Now if I just hold it down on that and wrap it around this post. Now, tack that wire onto the post. Let's see, where was it? Right over here. Okay, just like that. And now, I think I dropped my side cutters. Dang it. Hang tight, let me see if I can find my side cutters. Okay. Okay, clipped it off. That looks like it's repaired, okay. Okay, let me get set back up here and we'll check it out with the ohm meter. Okay, well first let's see if we can't look at the repair. And there it is right there. As you can see, I soldered that lead wire onto the leg, and then I bridged the two wires together. So I got the magnet wire soldered onto that piece of wire, and hopefully that's going to work. So let's go ahead and get the ohm meter out and ohm it out and see if we got continuity. Okay, so let's check our zero again. We're zeroed out, and let's see if we can get a reading here. 28.9 ohms. I say that's a success. Okay, good deal. Let's go ahead and put it back in the board. Should I try to cover it back up with the original paper? There's no stickiness to it, but for protection, I reckon I could. Let's see. All right. Good old packing tape. All right, just want a little piece. And let's see. I don't think this will have any adverse effect on it. And I need another little piece. Okay. Now, let me make sure I get this on the board right. Yeah, the green dot was factory here. I put the red dot on it. So the coil is on the inside, so we know the coil goes on the inside, so it goes on just like this. So hopefully these holes will line right back up. Without too much trouble. I get some solder off of this one. These are still kind of pretty banged up here. All right, I'm going to get two of them in first, then I'll get the other two lined up. Okay, they're in. Let me get these two in. Kind of tack that one in place till I get this other one started. Okay. All right. Let's check it now and see if we got our resistance still. $29.8. All right, what about the other side? 28.6. Woohoo! All right. We just might have a working board now. All right, let me go ahead and set it back up. Well, we can do this on the fly here. Okay, this is the one that we just fixed, yes. So let's plug this in. Plug that in. All right, turn it on, see what happens. Okay, it does that sometimes. Okay. Well, whoa. Looking good. The text is yellow anyway. Are we going to have a blue background? No, still green. But we got a red back. So that's better than it was. But we're still missing our blue. The blue is the other coil, the one that we didn't mess with. I wonder if we could have a bad chip. Because I think we were getting the correct reading on that. It was close enough, I would think. Definitely green there. But as it fades out, the blue came back in, didn't it? It's like the green is being overdriven. So that might be the chip, because the chip is like it's a preamplifier, it's an amplifier. Let's look at that one more time. See the transition between when the Space Invaders goes off. Maybe I was wrong about seeing it blue there as it faded out. But at least we're getting it back to where it was when I first got it. So that coil must have broke while I was, trying to figure out what was wrong. All right, and let's see what happens here. It's hard to tell. Okay, well, I wonder if you can piggyback that TBA 530 chip. Never hurts to try. What do you think? All right, let's see what happens. No difference there anyway. So I would think if it was you're not able to piggyback it, then it would be messing this part up too. So let's see what happens when we go to the Space Invaders. Yes, we got blue. So the chip is bad also. So we had two problems. All right. Okay. Boy, I always have to go through everything it's always just messed up. All right, no problem. I like fixing stuff. I mean, you think I could catch a break every now and then, but hey, that's okay. All right, should I cut this chip out since I'm pretty sure it's bad? And I have no other way of testing it because I'm pretty sure this wouldn't be in my Japanese or Chinese IC tester because this is, not a normal chip. I could cut it out, I guess. I'm going to go for broke. Let me just see how this works out. Sometimes this desoldering thing works good, and sometimes it's a pain in the butt. So far, so good. That didn't look too good there. Do that one over again. Yeah. This thing ain't sucking right. Not stopped up. Probably should have added some fresh solder to them. Yeah, some of them just don't look good. Okay, rest of them look okay. Let me try this again. If this don't get it, then I'm going to cut them out. All right, let's see what they look like. Maybe. Trying to get these out without breaking these coils. All right. There we go. All right, let's see if we did any damage to the board now. Board looks good. Got a couple places where I had to clean some solder up. They look okay. All right. This is my last 16-pin dual wipe socket. I got an order from Great Plains, which shipped today, and should be here Friday. Today is a Monday. They should be getting here Friday, which I believe is Christmas Eve. So, yeah. Okay. I'm also on that order waiting for parts for the Arcade Jason project. That ain't gonna work. I think it's holding itself in so I can get it tacked in. So, yeah, hopefully if that order comes in Friday, I'll be able to get back on that project. All right, make sure socket is in. All right, socket is soldered in. Let me take a look at it. Looks good. I need to clean it up with some alcohol though, but I'll do that later. All right, now let's put this new chip in, which is a TBA 530. Now, I went ahead, good thing I ordered this chip. I got it from Twisty Wrist. And I ordered 2 of them because I got my original that's in my Gorf game, and then I got this one for my test rig setup. So I was figuring that maybe one of them is bad here, and then I'd have an extra spare for my Gorf if that ever went bad. Because I think these are, they're discontinued, and while they're not hard to find right now, you're not going to find them everywhere, let's put it that way. So I figured I'd go ahead and get it and have it on hand. All right. Let's hook it back up and see if we got a working board. And let's try it out. Powered up. Okay, looking good so far. Let it get to the Space Invaders, and if we got a blue background and other colors, that should do it. All right, we got red, we got green, we got blue. I think we can call that a success. All right. Well, we had a broken coil on the delay coil, and we also had a bad TBA 530 RGB matrix preamplifier IC. All right. Well, I like a happy ending. Now I'll be able to put this board back in my Gorf, and I'll still have this for my test rig. So eventually I want to go ahead and fix this test rig up and mount all these boards so it's all in one unit, and so I can easily move it around and won't have to constantly be hooking everything up and putting it together. So, and also in the future I want to wire up the joystick and buttons so we can go ahead and actually play the game like this, which will complete the test bench setup for the Gorf. All right, well, I guess that's gonna end this video right here with another successful arcade fix. So this has just been another arcade fix. Have you had your arcade fix today?